So guys, this is our LM35 sensor over here. You can see that it is sending the data, and this is the CH340 USB TTL device. It is sending the data. Let me show you what is the data we are being receiving. So let's get to the terminal. See that it is the data coming from the sensor 21 degrees centigrade 20. Now I hold the sensor to change the value. See, now I am holding the sensor. Heat from my hand is being transferred. So value will please see, now it's 23. It is increasing 24. So it is working like a charm. So simple as that. Let me show you the code how it's working. Now take a look here. See that we just initialize the ADC pin for the sensor, UART for the CH340 USB TTL device. Then we fetch the data from the sensor. Then we converted it into a Celsius. Then we converted the integer to string, and then we sent it over the UART channel to our computer. Simple as that. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can interface the LM35 temperature sensor with a PIC16F877A microcontroller, and then we are going to send the output in Celsius form on a PC or a laptop, whatever you have, using a USB to TTL device. You can use any available USB to TTL device, FT232, CH340 or CP102 or any other. But remember, whichever device you use, you must install its driver first. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this over here is the LM35 DC sensor. So let me first label it for you. So as you can see that the part, as you can see on the LM35, you will see from where the writing starts, that the side where L is written of the LM35, that is the pin at that side is the VCC pin, and the center one is the output pin, and the right one is a ground pin, like this. Now guys, the next thing is we need to interface with the PIC. So let me show you how to wire it up. So guys, the VCC, you will connect it to the VCC of the PIC like this. Then for the ADC pin, that is the center signal pin, you can connect it to any available ADC pin of the PIC. So I'm going to use the pin number A0 like this. You can use any other pin if you like. Now guys, for the ground pin, just connect it to the ground of the PIC. Simple as that. That's how you can connect an LM35 DC sensor with a PIC16F877A microcontroller. Now guys, this is our USB to TTL device. I'm going to use a CH340. You can use any other device available with you which has the USB to TTL capability. Remember that whichever the device you use, every USB to TTL device have 3 pins in common: TX, RX and the ground pin. And we are only going to need these 3 pins. The rest of the 3 pins, 3.3 volt, VC 5 volt, they are optional. In some devices you don't have the option of 3.3, and in some you only have a VCC pin, doesn't matter. But TX, RX and ground are common in all the USB to TTL devices. So let me relabel it for you. The topmost pin, if you hold it like this, for the CH340 device is a 5 volt, then it's VCC, then 3.3 volt, then TX, RX and ground, like this. Now guys, let's interface this with a PIC. Now to interface this with the PIC, first of all, you connect the ground directly with the ground of the PIC like this. Then for the RX pin, you will connect it to the TX pin of the pin, that is pin number 25 of the PIC, and that is C6 pin. Then for the TX pin of the CH340 USB to TTL device, you will connect it to the RX pin of the PIC, and the RX pin of the PIC is the pin number C7, that is pin number 26 of the PIC. Simple as that. Now guys, we will not connect the 5 volt VCC 3.3 volt pins at all, because I will connect this device into the computer, and computer will power up the USB to TTL device, while PIC3 will power up my PIC. In case you don't want to use the PIC3, you just program the microcontroller once, then you remove the PIC3, and then you will connect this 5 volt pin to the VCC of the PIC. In this way, your circuit will be powered up by the computer. But in my case, I will power up the PIC and the LM35 using the PIC3, and this device will be auto powered up by the computer. Whenever I will plug it into the computer socket, it will be powered up using the computer's 5 volt supply. Simple as that. Now guys, let me introduce you to the hardware before we move on to the programming. So guys, this over here is the hardware. This is the CIC40 USB to TTL device, and this is the socket USB extension port coming from the computer, and this over here is the LM35 sensor. See that, simple as that, connected as shown in the presentation, and this is the PIC3. and this is our PIC16F877A. Rest of the wiring is just you can call it like it's just the trainer board, simple as that. So let's get to our MicroC for PIC. So guys, this is our MicroC for PIC. As you can see, let me zoom in so you guys can see better. It's a version 7.2.0. You can use a higher version as well if available, and I think 7.5.0 is right now available. You always use a higher version. Higher is always better. Click on File, New Project. This window pops up, New Project Wizard. Click on Next, write the name of the project. Whatever the name of the project is, I write LM35 USB to TTL tutorial learning microcontroller. So simple as that. This is the name of the project I wrote, and the folder is, this is the path where your files will be created, and this is the microcontroller selected. I'm going to use the PIC16F877A, and the clock of the device is 20 MHz. This is the crystal connected to the pin number 13 and 14 of the PIC. Now click on Next and finish. Now guys, as you can see, this window pops up. Before you do anything else, first of all, press Ctrl S to save your work. Click on Save. Now guys, go to the right, select the libraries we are going to use here. First of all, we will need the ADC library for the sensor because LM35 sends the output in ADC form. Then we cannot display the ADC values directly over the serial, so we will need to convert it into a string. So we will send the string. So select the conversion library. It will also auto select the string library. Now our USB to TTL device is a UART based device, so select the UART library as well for the UART device. Now guys, go back, go to the ADC library, expand it, and click on this ADC INIT command, double click. So here this window pops up, and in the example here you have this command, this ADC INIT. Copy it, go back, paste it with it below the void main like this. This command will initialize all the ADC pins of the PIC. So let me give some initialization delay as well, like this. So now the ADC pins are initialized and an initialization delay is given. This is not necessary to give the initialization delay, but I always suggest to give it in the one time loop. Then guys, the next thing is now we initialize our UART device. For that, go down. Here you have this UART library, expand it. Here you have this UART1 initialized, double click on it. Go down. Here in the example you have this command UART1 INIT. Paste it below the UART1 initialize like this. And this is the syntax of the command UART initialize. And this is the baud rate. You can set any baud rate that you like. In my application, I'm only going to send temperature data. So 9600 is more than enough. If there is a bigger, like you are going to send a whole assay, then you will need bigger baud rate. But in my case, it's more than enough. Now I give some initialization delay. This is not necessary to give initialization delay, but I always suggest give it in the one time loop. Now guys, our ADC pins are initialized, which means that we can connect the LM35. And this means that we have our UART pin initialized. This means now we can connect the USB to TTL device. Now the next thing is we simply now are able to go to the main loop. So now we go to our forever loop. Let me write here while 1. This means the forever loop will start from here and it ends here. Now inside it, first of all, we will need to read the value from the sensor. For that, we will need a variable which will store the value. So we take a variable IntTemp. This will read the value from the sensor and store it. So I write temp is equal to ADC underscore read from 0. Now see that temperature is the integer variable, and this is the command syntax from for reading the data from the ADC pin, and 0 is a channel. Like my LM35 output pin is connected to the pin number A0, so it's channel 0. If it was connected to the AN1, then I was to write here 1. Simple. Now guys, give some initialization delay. Not necessary, but I always suggest to give it for the smooth running of your program. Now guys, the next thing is we have read the value from the sensor. Now we need to convert it into a Celsius, because this will be a raw value, not of any use. Either we convert it into a Fahrenheit or a centigrade scale. So I will convert it into centigrade. For that, I take another variable int tempC for centigrade. Now what I do is that there are some standard equations to convert the LM35 value from raw to centigrade. So let's apply them. tempC equals to whatever the value is read, temp multiplied by the applied voltage. We are using 5 volt supply, so I will write here 5.0. If you are using 3.3 volt supply to run your microcontroller, then simply write 3.3 here. Whatever the supply you are giving to the microcontroller and the sensor, you will write that voltage over here. That is your V reference. Now close this bracket and divide it by 10. Because one step of this LM35 is 10 millivolt, so this is the standard equation. Now this is a standard equation. You have wherever you will use LM35, you will need to apply this to convert its output into a centigrade value. Now this will convert this. This is the raw value, and in this variable is stored is the centigrade value. Now we give some initialization delay like this. Now guys, the next thing is we cannot send this value directly over the serial to our computer screen, because computer works on ASCII, American Standard Code for Information Interchange. So if it is not ASCII, then we cannot read it. So we have to convert it into a string. String is basically ASCII format. So for that, go to the right. We had selected a conversion library. This library, expand it. In that, look for a command called IntToStr. This command. Double click on it. Now in the example here, you have this command. You copy it, go back, paste it like this. Now guys, here you will write the integer whose value is to be converted like this. Whatever is in the integer, whatever the number is in the integer will be converted into a string, will be stored here, and we will need a array of char. An array of char is a string, so we write an array of char. tempC1 I name it, and maximum characters it can hold is 5. 0 to 4 means 5. So now whatever the values in this integer will be converted into a string and will be stored in this array of char. So like this. Now that's how this command is going to work. Whatever the integer is here will be converted into a string and will be stored in this char variable. Now give some initialization delay for this command as well, like this. Now guys, we have our temperature value in string, and now we can send it over the UART channel. Now to send it over the UART channel, go to the right, go to the UART library. Here you have this command UART1TX idle. Double click on it, and in the example here you have this command. You copy it like this only till here, go back, paste it here, and apply the ending brackets. This is a starting bracket, this is the ending bracket. Now this command UART-TX ideal, this checks the UART buffer if the TX pin is ready to send the data. If you do not use this command, it doesn't matter, it will still work. But there is a problem of distortion. But if you use this command, it will only send the data when the buffer is empty. So in that scenario, there will be no distortion and your data will be very smooth. So now what we do is that we go to the right again. In the UART library, you have this command UART1 write text. Double click on it and copy this command only from here, this UART1 write text. Go back, paste it below this inside the bracket. And now send whatever you want to send. First of all, we will need to send this data, tempC1. Now this is the temperature. Whatever the temperature is in this will be sent to the computer. Now before that, to make it look presentable, I do is that I send a string that space temp is equals to, and then 2-3 spaces. So then the temperature will be displayed, and after displaying the temperature, like this, then again we send something so we can make it look more presentable. We send that C. C means it's centigrade, and after that the value is empty. We send 2 stars. It means that this value has ended. Sorry, just send star shift plus 8. 2 stars and 2 stars at the starting, like the value starts here, ends here, in the center is the value. Now since this data will be very fast, we will not be able to read it, but in my application I will slow it down using a delay, so we can read it data in better way. So I give a delay of like 250 millisecond. After every 250 millisecond, it will send a new value to the computer. Now I build this code. Okay, it's built successfully without any errors. Let's build it again. Okay, it's built. Now let's go to the PIC16 programmer tool here. Select your microcontroller. PIC16F877A is the one I'm using here. So here it is. I go to the file, import hex file, and this is the file we just created. Double click on it, click on write. Okay, the new file is being written. Let's get to the hardware and see what happens. Okay, let us write the new file. Okay, it's written. Okay, our new file is written, and let me power up the circuit using the PIC16 programmer tool. I turn it on. See, the data is being sent. You can see the blue LED blinking. This means the data is continuously being sent by the PIC. Now let's see what is being sent. Let me go back to the MicroC for PIC and turn on the USART terminal. Zoom in. Here in the tools, you have here USART terminal. Click on it. Select the port. COM8 is my port. And in your case, whenever you will install the driver, it will assign a port to that USB device. So 9600 is the baud rate we set in the programming, so it will be the same. Select it and click on connect. Okay, we are receiving the data 20 degree, 19 degrees centigrade. See, it is giving values, so let's check it. Is it correct or not? So here we are getting our values. So what I do is that, okay, we are getting the values here. Let me move it so we can see it. Okay, I place my finger on this LM35 to change the value. See, the temperature is rising. It's now 22, 23, 24 degrees centigrade because I am holding the sensor. See, heat from my hands are being transferred to the sensor. See, now it's 24. See, so it is working perfectly fine. Now I release it. See, now it has reached 25 degrees centigrade. See, now I have left the sensor, so the values will start to decrement now. Okay, let me open the terminal. See, now again the values are falling. It is falling 23, 22, 22 degrees centigrade, and now it will fall further because I had left the sensor. 21. Now again I hold the sensor and we see how the values change. So I hold the sensor again to increase the temperature. See, I'm holding the sensor and the value has reached 24 degrees centigrade. Now I release the sensor again. Again the value will start to drop now because I had released the sensor. See, no one is holding it. See, it is falling now. It's 23, 22. So guys, it is working like a charm. Now guys, if you have any questions, you can ask me in the comment. Thank you very much for your time guys, and this code I will share, the code I just wrote right now, I will share in the description of this video. So I hope you guys learned something from this video. Thank you very much for your time and have a nice day. We'll see you in the next video.